is good. Okay. So today we are going to discuss about a new topic, right? That is work, energy, and power. Okay. So work, energy, and power is almost the second last chapter of your general physics, and right after that we will be going through pressure, and inshallah general physics block will be finished out. So in this work, energy, and power, what do we have? We have to talk about work, energy, power, efficiency, then energy resources and all that stuff. Okay, so we will start from work. Actually, these are two chapters in your book, if you remember. Energy, work, energy, power, and energy resources. So first we are talking about work, energy, power, and then I will go to the energy resources and then give you some sort of idea. So work is, क्या होता है work? If you just consider work in your daily life, so work is basically the product of force and the distance in the move in the direction of force, right? For example, if I have some block here and I'm going to apply some force on this, and it is covering distance d in the direction of applied force, then work will be the product of force and distance. We can also call it displacement. Don't worry, both are acceptable. Okay, so Khadija, what is the definition then? The product of force and displacement, product of force and distance in the direction of force. So you can use any one of the definitions, but if you use displacement, it would be worthy than product of force and displacement. So then you will have no need to write in the direction of the force. Okay, it's actually its unit is joule, which is considered as Newton and meter. Okay, so uh, this is simple one. I don't think so. It is somehow difficult, but when we will talk about that how to measure or what is the joule measurement, so 1 joule is work done when a body is applying 1 Newton constant force on a body and it travels a distance of 1 meter in the direction of the force. Then we say that the body is covering actually, or the work, one joule is the work done on the body. Okay.
Mm-hmm. Yes, sir.
So there would be some sort of calculations coming from your work, simple calculations. I think it is not complicated. You will be given some sort of force, and for example 50 Newton force is applied to drive a body through 3 meters. Then you can simply have the work equals to 150 joules, right? And if work is given to you, for example 210 joule is work given to you, and you are applying some force F on the body to move it through a 3 meter distance, then how much force is required? Then force will be equals to 210 by 3, which is 70 Newton. So this is a very easy and gentle equation
Mm-hmm.
to be used for work. ठीक है, वर्क के लिए इक्वेशन कोई मुश्किल नहीं है. Just you have to consider this triangular setup, that yes, if you are having the equation like a triangle, so you can say that, for example, this is work and that is equals to force, that is equals to distance. That's it, right? So anything can be calculated from this triangle. You have to recall that equation. Is it
Sir, can
easy?
I be back in like 10 minutes?
Yes. Okay. So right after that, there are some conditions in which there is no work done at all. No work done means under some circumstances you are trying to do some work, but no, it is not under physics. For example, what is that condition? Just see the formula, that W is equals to F times D. If you say that this distance is equals to 0, then work is equals to 0. Okay, isn't it? When this distance is equals to 0, Khadija, are you there?
Yes, sir.
ओके बस तुमने क्लास में ही रहना है, ठीक है ना. When distance is equals to zero, then work will be equals to zero. This is one condition, that the body is not moving. It means you are trying, but body is not displaced. So displacement is zero, work done zero. Second very important condition, then when work done and sorry, the direction of force and direction of displacement are perpendicular to each other. Perpendicular to each other means, here are some examples. For example, this student is applying some force on this box, and the box is traveled, or box is compelled, sorry, pulled through a distance. So it means she is doing some work is there. But she is lifting a bag, check, the force applied on the bag is upward, but she's traveling in this direction, so both are at 90 degree to each other, right? If I just draw it here, this is force and this is displacement, so they are at 90 degree. So when they are at 90 degree, there is no work done at all. Okay, because I will explain it to you. If you recall one equation, although that is in your A levels, it is not included here. I mean, you will not be asked by this one, but actually the general formula for the work is F D cos theta, right? What is the general formula for work done? F D cos theta, right? And in this case, for F and D, and if you put theta is equals to 90 degree between distance, and for example force is applied in this direction, this is the force and this is the displacement, so both are at 90 degree with each other. When they are at 90 degree, then cos 90 goes to 0, so it means your work is going to be 0, right? What is work? Work is going to be 0. So remember one thing, when you are going to apply some force perpendicular to the body's displacement, you are doing no work. So here she is doing some work. When she is going to lift it up, she is doing some work to lift it up, so work is there. But when she lifts it up and she moves forward, there is no work at all. So these are the circumstances in which work done is 0. Is this clear to you?
Yes, sir.
Okay, the next situation is energy. Actually, energy is a sort of ability of doing work. It's capacity of doing work also. It is measured into joules. Its unit is joule, scalar quantity, and energy has magnitude only. What does it has? Energy has only magnitude, no unit at all. Then we have different forms of energy. I will talk about that just in the next slide. Here is the law of conservation of energy, or principle of conservation of energy, that is also named as law of conservation of energy. Law of conservation of energy. So I can say that energy law of conservation of energy is asked to you for 2 marks usually, not more than that. And this law has three aspects for definition. First, that energy can be converted from one form to another form, but total amount of energy remains conserved or unchanged, right? No change in energy takes place. Secondly, total amount of energy of a closed system remains constant. Third, the energy can be converted or transferred from one form to another form without any loss. So these are three statements. You can choose any one of them by your convenience. All are correct. They will give you, or they will award you the marks. So you can consider law of conservation of energy in this way. So is it clear that when it would be asked to you that state law of conservation of energy, so will you be able to do that, or will you be able to handle this one?
Yes, sir. तो इन तीनों में से कोई से भी लिख सकते हैं ना?
कोई भी लगा सकती हो, यस. ठीक है. Okay, now there are forms of energies. As I told you that I will discuss these energies, forms of energies later on. So there are several forms of energies which are actually consider in our daily life. One of them is potential energy. Potential energy is a sort of hidden energy, right? What do we call it, or why it is potential? It is hidden energy. So that energy can be further types. That can be elastic potential energy, that can be gravitational potential energy, that can be chemical potential energy. There are so many types of potential energies, but generally, you know, what we have to discuss, that is this one, GPE. We will talk about this one. And elastic potential energy we have studied about, if you remember, EPE. In the last deformation chapter, we have studied EPE, elastic potential energy. So then kinetic energy, that is combinedly kinetic plus potential, that is mechanical energy. Then electrical energy, that is energy due to free moving charges or charged bodies. Then thermal energy or heat, then light energy, then sound energy. There are so many. I have not listed all of them. Mostly the energies which are available: nuclear energy, then you have tidal energy, right? Then you have geothermal energy. There are so many further classes. Okay.
Yes, sir.
Okay, is it clear to you, or is there any other name in your mind for kinetic, for the forms of energies?
It's like एक थी मुझे याद नहीं आ रहा. Mechanical.
हाँ हाँ, strain energy.
Yes, sir. और sound energy भी है.
हाँ, sound energy है, I have put over here.
But वो तो एक chapter आता है ना, एक पूरा chapter है जिसमें solar
हाँ,
energy
वो
वो
चैप्टर है.
power वाला.
Solar, yes, you can write solar. That is the energy transfer. So there are so many forms of energy. Solar energy, right? Is it clear? So these are some names which are included in your syllabus here as well. ठीक है ना? So you can remember all these names. So let's talk about uh, kinetic energy and potential energy first. So kinetic energy is actually the energy which is possessed by a body due to its mass and speed. Actually, motion mean due to its speed. So if I say that a body has possessed its mass and speed, that body possesses kinetic energy. So you have to calculate, or you have to recall this formula, please. This is very important formula for the calculations. Kinetic energy is equals to 1 by 2 mv square. What is that? 1 by 2 mv square, where m is the mass of the body. Okay, mass of the body. V can be the speed of the body, because here it is squared na. So that's why velocity, it does not matter कि velocity है या speed है, both have same mechanism, right? So because that is a scalar quantity, so that's why, as I told you, that its only magnitude matters. So moving object has kinetic energy, but the object which is at rest, it has no kinetic energy at all, whatever its mass is, right? Did you
Yes.
get it? If a body
Yes,
is
sir.
at rest, it has no kinetic energy at all, because it's one of the factors is zero, velocity is zero, or speed is zero. So you can consider this. So SI unit of the energy is joule. So here is a car that is having some mass and it is moving with certain velocity or speed. So we can put this formula 1 by 2 mv square to calculate its speed. For example, if I say that mass of the car is 1200 meter per second and the speed of the car is, suppose, do you have calculator?
Yes, sir.
Yes, sir.
Okay, so let's say its speed is 27 meter per second. Then what will be the kinetic energy possessed by this car? You will use formula 1 upon 2 m v square, and it would become 1 upon 2. Mass is 1200 and speed is 27 square. So just tell me the answer.
That would be 437,400.
437,400 joule. So we will round it off to 4,400,000,000 joules because of two significant figures, or you can simply say 440 kilojoules. 440 kilojoules is the energy, kinetic energy possessed by this car while traveling with this much speed. So is it clear to you?
Yes, sir.
Yes, sir.
Okay. Now, if the same car is given to you and some energy is available and you are supposed to calculate speed of that car, for example, the same calculation, I mean same car, its mass is same, 1200 kg, okay, and it is said that the car possessed 60 kilojoule of kinetic energy. Calculate the speed of the car by which it is moving. So I have just rearranged that equation for you for convenience. K V is equals to what I did actually. Let me explain it for you first. Ke is equals to 1 by 2 m v square, because my subject is v. I want to calculate v, so I will just put this 2 on the other side. It will become 2 ke, and that is now m v square. For further calculations, v square is equals to 2 ke divided by m, and for further calculations of v, I just take square root on both sides, and I will get that velocity of the car is 2 ke divided by m square root, which I have just printed out here. So just put the values. I mean, instead of deriving this in exam, if you remember 2 ke by m square root, then just you will plug the values in. 2 times 60,000 divided by what was the mass of the car, 1200, and just take square root. So what will be the speed of the car? Yes, what will be the speed? Why? Calculations, please.
Sir, 10?
10.
Yeah.
Na karo. Because when its speed was 27 meter per second, its kinetic energy was 440 joules. Okay. Yes, that was 440. Sorry. So it is 10 meters per second. That is the speed of your car. So just remember one thing simply, that for kinetic energy calculations, nothing difficult. Kinetic energy will be multiplied by, sorry, if speed is double, kinetic energy will be 4 times. Will you be able to manage this? If V is multiplied by 2, kinetic energy is multiplied by 4. But if mass is multiplied by 2, kinetic energy is multiplied by 2. That's it. Got it? So you have to use this.
मीन
Sorry?
तो इसका क्या मतलब हुआ कि कब
इसका मतलब ये हुआ कि when someone is asking that the car is moving with certain speed and its speed is now double, so what will happen to its kinetic energy? So kinetic energy will become 4 times.
अच्छा
For example, here, if the car of the speed of the car becomes 20 meter per second, then what would be the kinetic energy? it would be 60 times 4. So it would be 240 kilojoule, because speed is double, right? So kinetic energy would be increased by 4 times.
ठीक है सर.
Okay, is it clear? So if your
Yes.
mass is doubled, mass is multiplied by 2. So let's say car was 1200, now this car is 2400 kg, then kinetic energy will be just doubled. Okay, kinetic energy will be just 60 times 2, so it would be 120 kilojoule. So this is what you people can be asked in MCQs and in theory in this way. उसके बाद आपके पास आ जाता है जी potential energy. So potential energy is again a topic which is dealing with your energy stored in a system, especially mass. So there are types of potential energy, as I mentioned, that there are several types of potential energy. The chemical potential energy, which is hidden in or which is available in wood and burning of chemicals and all that stuff. So chemical potential energy is converted into thermal energy when we burn the wood. Then the elastic potential energy is stored in the rubber bands and all those stuffs which are stressed are deformed, right? And elastic potential energy is stored in stretched rubber band, spring, and wires, and etc etc. Then gravitational potential energy is the energy which is basically defined as the amount of work done due to rise or raise in the body to a height h from a surface reference level, or simply speaking, the energy possessed by a body due to its mass and height. Simple and non-error, error free, right? It is basically error free definition. So when you are going to write this, that the energy possessed by a body due to its mass and height from the surface of earth, or that's it. If you don't write from the surface of earth, तब भी आपको number मिलेंगे. Okay, because it is understood that we are taking the height from the surface of the earth. Its formula is GPE is equals to mgh. You have to recall this formula, please. It's quite easy to recall. Okay, where m is the mass, g is the gravitational acceleration or acceleration due to gravity, and it is basically in meter per second square, or ms minus 2, and height is in meters. So of course it's not a big deal for you people to calculate. Here are some important points for that. This is very important. When an object is raised to a certain level height h, it has the gravitational potential energy, but when that object is released from that height, the object will have all of its gravitational potential energy gradually converted into kinetic energy just before it hits the ground. If air resistance is not, this is important, that if there is no air resistance, then all of the kinetic energy, all of the potential energy which it possesses at height, it will be converted into
Kinetic energy.
kinetic energy. That's it. Yes. So here is a diagram in which I have tried to show the interconversion of energy. This is a stone or a rock, and that person is holding it at certain height h, and at this point it is at rest, but it has all of its energy as potential energy. So I can say that its energy is gravitational potential energy there. Changing machines. Okay, but as it moves down, check this blue, red is not there, huh? Or just assume that there is, this is that kinetic energy. Basically kinetic energy is equals to 0, but as it moves down, the blue one decreases. Why? It means blue decreases mean GPE decreases, your gravitational potential energy decreases, and kinetic energy actually increases. What happens to kinetic energy? kinetic energy increases. So there is a stage when all of the potential is converted into kinetic. Okay, all of the potential is converted into kinetic energy, and that is when the ball hits the ground. Here, no potential at all. Okay, GPE, I mean this is GPE is equals to 0. This is just U को आप लोग लिख लो GPE. U is basically GPE. Okay, is it clear to you?
Yes, sir.
Kinetic energy plus total energy is basically written as kinetic energy plus GPE. So that is the total energy. TE, total energy. Total energy is equals to 1 by 2 mv square plus mgh. राइट, तो टोटल एनर्जी के लिए फॉर्मूला क्या हो गया हमारा 1 by 2 mv square plus mgh. So simply speaking, if your kinetic will be 0, potential will be maximum, and when potential will be maximum, here at this stage kinetic is maximum and potential is 0, and at the height potential is maximum, kinetic is 0. Is this clear to you?
Yes, sir.
Okay, so energy lost due to resistive force, when there is a resistance I mean when you are going to drop a body and there is a resistance available, then actually this is all that in real time this happens, that energy is converted into into heat loss, because total energy is not converted from one form to another form, or kinetic is not converted into from total entirely into potential. Some of the energy is lost to the surrounding, and that lost energy is actually the energy dissipated. So I can simply say whatever the details are there here in real world, the reference force of friction and drag force are there, and then thermal energy appears, and that thermal energy is basically the dissipation of energy or energy lost to the surrounding. So kinetic and gravitational potential energy, they are interconvertible but not completely. So please note down that energy is still conserved. Energy is still conserved. Mind it. It means although kinetic is not converted into potential completely, but heat loss is a form of energy. Na? So here just consider that when one energy is being lost, other is gained. So their difference must be equal to 0. Here I'm going to write it again, that in vacuum, loss minus gain equals to 0. When one energy is lost and the second one is gained, so their total sum goes to, I mean difference goes to 0, right? That is why loss energy is equals to, so lost energy is equals to gain energy. Are you getting it? But in real world, loss loss is always greater than gain. Gain is always less. So that means the difference between loss and gain, that is equals to energy lost in the friction, energy dissipation, and that energy dissipation is basically work done against friction. So you can simply say that loss minus gain is equals to work done against friction. Okay, so for example, if your one energy is being lost, kinetic potential is lost and kinetic is gained, so you will write in this way. check this one out, that loss in GPE minus gain in KE is equals to work done against friction. Okay,
Yes, sir.
ये important topic है, very important, very important. For example, I will just uh, plug in a page here to make you clear. Here is the interconversion of energy. For example, there is a slide, a ball is rolled down, okay, and that ball is just reached to a certain level over here. This is a ball. When it is exactly at this point, it has some speed, or you can say it has some sort of, it is at rest exactly at this point. Okay, its mass is given to you. What is its mass? Its mass is, suppose, 5 kg, right? And it is at rest, 5 kg at rest. The height above the ground, that is your 20 meter. How much height does it have? 20 meter. Are you getting it?
Yes.
Okay. Now this ball is rolling down and down and down and down. When it reached to this point, to the ground, it has lost some of the energy. है ना?
Yes, sir.
Mm-mm.
And that energy is coming from where? That energy is coming from its loss in height. As it has lost the height, that is why it is gaining its kinetic energy. So it is rolling down. When it is rolling down, you can simply say that it is having certain velocity here. So here, I will draw two circumstances. Without friction, without friction, no loss in heat. Sorry, no energy is lost as heat. Without friction, calculate final speed at point. This is point A, and let's say this is at point B. So final speed at B, speed of the ball at B, right? So how to do that? Loss in energy is equal to gain in energy, na? Will I use that one?
Yes, sir.
So I will say that loss in which energy is loss? Loss in
GP.
GPE is equals to gain in KE. Okay, so it is mgh, and that is equals to 1 upon 2 m v square. So just cut these m's because mass is mm, conserved. So v square की calculations करिए जरा. V is equals to 2gh square root. Simply just put the values here. 2 into 9.8 into 20, and give me the final answer. क्या स्पीड आएगी इसकी? 19
So
point something है?
calculate. करना है।
जी खदीजा, क्या
जी
आंसर
सर
आएगा?
19.7 है।
19.7 meter per second. That is the speed of this ball. 19.7 meter per second. Is it clear? Now I will consider the same case, and that case is the ball is sliding down. Now case 2, same ball, same mass, everything same. So when everything is same, just there is a track has some friction. This is a rough track. The previous one was a smooth track. There was no energy dissipated. The same track, but this is just the height of the track is same, 15 meter, sorry, 20 meter. Same situation here. Okay. Now I will just make it rough, a bit rough. Here. This is a rough track. Okay. So it has friction. So when it will be having when we will consider that all our calculations, if the speed of the ball is, I'm just going to give you that speed is suppose 12 meters per second when it reaches to the ground. How much speed does it have? 12 meter per second. Then calculate work done against friction. Work done against friction. Yes. Now, is this very clear to you that loss in gravitational potential energy is equals to loss in GPE minus gain in KE is not equal. That is equals to work done against friction. Are you getting it? That was the formula what I have given to you. So work done against friction was equals to what? Loss in GPE minus gain in kinetic energy. So that is mgh minus 1 by 2 mv square. That is equals to work done against friction. So m is what was the mass of that body? 5 kg. 5 kg into 20 meter height into 9.81 minus 1 upon 2, 5 kg mass, and speed is 12 square. So just please give me the number.
So wait, let me calculate.
Yes, yes. Come on, please.
So 621.
621 joule is the work done against friction. Is it clear?
Yes, sir.
Okay, good. So you have calculated that it is 621 joule. Now my next part is calculate the frictional force. Calculate the frictional force. For that purpose, Khadija, are you there?
Yes, sir.
Okay. I'm going to give you the height of this track. Let's say height nahi deta balki. Let's make it here. Suppose it is 40 meter. This one is 40 meter. So how will you calculate frictional force? You have calculated work done. So work done is equals to F into D. You have to calculate F. F is equals to what? Work done divided by D. तो बताइए.
अच्छा
Yes, Zainab, which
1D 621 है.
621 is the work done. What
Distance.
distance will you use? Yes, this is the
Hmm.
game. You know, the distance used will be actually this one, the slant distance, that one.
Sir, height नहीं use होगा.
नहीं, height नहीं use होगा ना, because friction is applied against this track, this one.
Mm-hmm.
Got it? So you will use that distance, and that length as a distance. So that is your D, which is used in this case. So use करिए जरा D calculate करिए. So the distance is required. Distance is equals to, this is basically the right angle triangle, right? So this is your 40 meter. This is your 20 meter, and you want to calculate this one. Okay? So that will be equals to 40 square plus 20 square root. So what will be that distance? हाँ जी, कैलकुलेशन शाबाश.
Sir, 44.7.
44.7
7.
कैलकुलेशंस. खदीजा कैलकुलेटर है?
Yes, sir.
तो कैलकुलेशन करके बता दो ना जल्दी जल्दी. शाबाश.
13.8.
44.7.
4 is fine. 621 divided by
अरे
44.7.
तुम कहाँ थी इतनी देर से? हमने डिस्टेंस फाइंड करना था. ये 40 का स्क्वायर प्लस 20 का स्क्वायर रूट करके दो. जल्दी करो. शाबाश.
Oh, अच्छा. $44.7.
हरे अप हरे अप हरे अप.
Sir, 44.7.
ये देखा, उसने बेचारी ने इतनी मेहनत की थी. 44.7 बगैर कैलकुलेटर के सॉल्व किया था उसने. तुम कैलकुलेटर के साथ भी सॉल्व नहीं करके दे रही हो हमें. 44.7 will be used. So now calculate frictional force.
Sir, 13.8.
Yes, 13.8, which is equals to 14 Newton. So please remember one thing. सीखा ये हमने कि the frictional force will be calculated by dividing the distance at which friction is applied. ठीक है ना? Friction is applied along that track, right? So just consider this as a final statement that frictional force is work done against friction divided by distance at which friction is available, at which friction is there. ठीक है? So this is basically the calculation which is being asked to you. सही?
जी sir.
Yes. So we will wind up till this point because next one is power and efficiency. I will try to calculate these two or to handle these two together. So till this, if you have any question, you people can ask me.
No sir, no question.
No question.
Mm-hmm.
Okay. ठीक हो गया. So see you then inshallah in
ठीक
my
है,
next
Allah
class.
Hafiz.
Allah Hafiz.